You're done? Okay. I'm gonna wait for people to finish. Done, right? Okay. 10 more seconds. Okay, let's get started. I'm gonna choose someone on random to do this with me. Nathaniel, can you unmute your mic so you can solve this with me?
Okay.
So what'd you do first?
I plugged in the -1 to the y and the 6 to the x.
Yeah. Okay. So what did you get after you did all the math?
I got -1 equals -1.
Okay. So this is true, right?
Yes.
So is 6 -1 a solution?
Yes.
Okay. Thank you. So 6 -1 is a solution to y -2 over 3x plus 3. Because whenever we plug in the x and y coordinates, we get a resulting true statement. Another way you can do this, and what the textbook said, is that you can actually just plug in the x value by itself. -2 over 3x. I mean 6 plus 3, and you should get -1. You should get -1. So let's see. -2 times 6, -12. This equals -4 plus 3, and that is equal to -1. So because you get the -1 as your y coordinate, you also know that this is a solution. So there's two ways you can do it. You can get a true statement, or you can get the y coordinate when solving for the x. So you get y equals -1. Okay. So does this make sense for everybody? Thumbs up, thumbs down. Yeah. Oops. Go back. Okay. So you said last time that this y equals 2x minus 4, this kind of form is slope-intercept form. So we're going to see how we're going to convert from standard form, ax minus, plus by equals 12. And then we're going to convert it into slope-intercept form. This y equals 2x minus 4. So the way to do this is you just have to rearrange the variables using the properties of equality that we discussed a few weeks ago. So 6x minus 3y equals 12. We're given this as our standard form. We want to get to this. Subtract 6x from both sides. 6x cancels out, so you're left with -3y. And you bring the -6 here. See whatever you do on the left, you do on the right. So -3y equals -6x plus 12. Divide -3 on both sides. The -3 cancel out here. And you're left with y equals, whenever you divide something and you have an addition operator, you divide whatever you see on the left, and you add it to whatever you're dividing on the right. So you're left with negative 6x divided by negative 3 plus 12 divided by negative 3. So the negative 6 divided by negative 3 is 2. So, and the 12 divided by negative 3 is negative 4. So you're left with 4 equals 2x minus 4. So this is how you convert from the standard form to slope-intercept form. We're going to use this whenever we're finding solutions from standard form. This part makes sense because we're going to be using this later. Good. Okay. So finding ordered pair solutions from standard form. In this example, we're given 5x minus y equals 14. And the x value is negative 2, negative 1, 0, 1, 6. And we're trying to solve for y. For each of these x values, we're trying to find the y coordinate for them. So here, the first thing to do is to isolate y, bring it to slope-intercept form. So we're given the equation 5x minus y equals 14. To isolate y, we're trying to get y by itself. We bring the variable x term to the right side. So we subtract 5x from both sides. 5 the x's cancel out. We're left with negative y equals negative 5x plus 14. Well, we're not done yet. Still have a negative. We want it to just be positive y. So we can use the multiplication property of equality, multiply negative 1 on both sides. So negative 1 here, negative 1 there. Then negatives cancel out, so you're left with positive y. And you have to distribute the negative to both 5x and 14. So negative 1 times negative 5x is 5x. Negative 1 times 14 is negative 14. So 5x minus 14 equals y. Now, we have to find the y coordinates to the x values. How can we do that? All we have to do is plug in the x values into the equation to find what y is equal to. So first x value we're given is negative 2. Just plug in negative 2, you get negative 24 as your y value. So the solution is negative 2, negative 24. The second x value, negative 1. Negative 1, just plug it in, you get negative 19. The solution is negative 1, negative 19. The third x value is 0, you get negative 14 after doing all the math. So what to grab from all this is that whenever you're trying to find the y coordinate, the y value, you just plug in the x coordinate wherever you see an x, and you solve for y. That's what your y coordinate is. So this is why we have this. It's easier to have this than standard form. Easier to make it in slope-intercept form. Did this make sense for everybody?
Yes.
Yeah, it makes sense. I know it's a lot at once. Okay, so we learned how to convert from standard form to slope-intercept form. But in the previous example, we were given certain x values. We're given these x values, negative 2, negative 1, 0, 4, and 6. We're not always going to be given x values to solve for y values. You can actually solve for any ordered. You can solve for any ordered pair. You don't have to be given x values. That's not always going to be the case. If we treat x as an independent variable, we can choose any value for x and substitute them into the equation to find the corresponding values. So we can put any number for x as long as we plug in the value where we see an x and we solve for y. So we're going to see how to do this in this example. They tell us to find 5 ordered pair solutions to 6x plus 2y equals 10. So the first thing we need to do is solve for y. We need to isolate y by converting it into slope-intercept form. We use the subtraction property of equality to bring negative 6 on the right side and isolate the y variable term. 2y equals negative 6 plus 10. So we want to isolate the variable y, so we get rid of 2. Divide 2 on both sides, division property of equality. 2's cancel out. We're left with y equals negative 6x divided by 2 plus 10 over 2. So 10 over 2 is 5. Negative 6x over 2 is negative 3. So we're left with the slope-intercept form of y equals negative 3x plus 5. This is step 1. You still want to plug in any values for x. So these are some sample values, negative 2, negative 1, 0, 1, and 2. All you have to do is just plug in these numbers wherever you see an x. Whenever you see an x, you plug in negative 2, negative 1, 0, 1, and 2. Then you just solve it as using PEMDAS, parentheses, multiplication. Negative 3 times negative 2 is 6. 6 plus 5 is 11. Do the math, and this is you get all the y values at the end. So once you get all the y values, you can make ordered pair solutions out of them. So we plugged in negative 2, that's our x coordinate, and our y coordinate is the solution. What we got for y, 11, negative 1, 8, 0, 5, 1, 2, 2, negative 1. So you can plug in any value for x as long as you substitute it wherever you see the x variable, and you solve it using PEMDAS, and you get the y coordinate, and you get an ordered pair solution. Was this good? Makes sense? Thumbs up. Yeah. Everybody else, feel free to interact too. Yeah. I want to make sure that everybody's getting the concepts. I don't want to keep going and going and going without everybody understanding everything. Yeah. Here's some independent practice. Try it. Find 5 ordered pair solutions to 10x minus 2y equals 2. Okay. We're gonna wait for 3 more minutes. Okay. We're gonna wait for another minute. Yeah. 15 seconds. Okay. Let's go over it. Okay, I'm gonna pick on someone on random, by random choice. Uh, Joseph, do you mind unmuting your mic so that we can go through it? Hello? Joseph, do you have a mic? If you don't have a mic, you can just type in the chat that you don't have a mic. Okay, seems like you don't have a mic. Mikios, you're the first person to finish it. You wanna unmute your mic and show everybody how you did it?
Alright, so first it was art. It wasn't what's it called? It was a standard form, so I switched it to slope by negative 10x to both sides, and then I got negative 2y equals negative 10x plus or 2 minus 10x, and then I divided negative 2, and then that gave me negative 1, and that gave me yx is negative 1 plus 5x. Uh, yeah, and then I just plugged in random numbers, and then so our first number put 2.
Okay,
First number I put in 2, then I got 9.
okay,
Second number I put in negative 1, and I got a negative 6.
Okay.
Second number I put in 3. Then I got 14.
Fourth number.
Huh?
Fourth number.
Fourth number I put in 4. I got
the
yeah
last
9.
number.
I put in 5.
Okay. So, in order to pair, you just have to combine the coordinates, right? Thank you. Very good job. Can anybody put, okay, so thing about this problem is that you can have any 5 ordered pair solutions. You can have 100, 1 billion. It can be anything. But as long as you plug in the x value into the equation and you solve for y and you get an ordered pair solution, then it's correct. Can someone put an ordered pair solution that they got from plugging in a different x value in the chat? Anybody, if you. Everybody got the same numbers? There must have been someone that used a different number than 2, -1, 3, 4, and 5. None? Okay. So let's say I plugged in 0. If I plug in 0, then this is my equation. Usually there would have been x here, but I plug in 0. 5 times 0 is 0. 0 plus -1 is -1. So then I get the ordered pair solution, 0, -1. This is the ordered pair solution. Did this question make sense for everybody? I'm pretty sure I don't have any difficulties. If it did, type it in the chat. If not, thumbs up. Yes, as in it was good, or yes, as in you have a question. You understand? Okay. Thank you again. Um, and I'm looking at this one, whether it takes too long. Okay. So I'm just going to go through this. I'm only going to go through the guided path. Actually, I'm just going to go through this. Okay. So plotting linear equations. Since the solution to linear equations are ordered pairs, they can be graphed using the rectangular coordinate system. The set of all solutions to a linear equation can be represented on a rectangular coordinate plane, this graph thing right here, using a straight line, collinear points. They're connected in a line. A line, I think we defined this in the first week of instruction. We went through what a line is. A line, like a line segment. This is a line segment, 2 points connected by a line, but it goes infinitely in both directions. This is a line. You can have points here. You can have points all the way, in any direction right here, as long as it's on the line. So this is the graph. This line is called the graph of this function right here, of the equation. So to illustrate this plot, 5 ordered pair solutions, -2, 11, -1, 8, and 0, 5, 1, 2, 2, -1, 2, the linear equation 6x plus 2y equals 10. So they gave us 5 ordered pair solutions to this linear equation. So they plugged in some random numbers and they solved for the y variable and they got these ordered pair solutions. So now they're going to plot them on the graph to see what happens. So these are all solutions to this equation. What happens is that all these points are collinear. They're collinear. So they make a line. Let's say that you plugged in another, okay. I'll show this to you later. I'm going to show you something. Okay. The screen. Okay, so this is Desmos. It's a graphing calculator, an app. Sometimes if you don't have a graphing calculator at home, you can use this website to graph things for you. So we're given 6x plus, actually, 6x plus 2y equals 10. So this is the graph that we're given. So this is a point, what is it? 1, 2. Let me check something. Okay. So we're given all these points and they're in a line. Okay, so I'm gonna zoom out of this graph and we'll see what's gonna happen. So this line keeps going on and on and on. Here at 100, we have, they're actually going in decimal places. So here at 100, we have a point. You're gonna see how far it goes. Here at 15,000, we have a point. Here at 600,000, we have a point. So the line goes on forever and ever. You can plug in any x. You can plug in any x value, and you get a solution. You get a solution to this graph. So the line goes infinitely in both directions. So the solution to linear equations, whenever you plot them, you're going to get a line graph. The thing that I wanted to show you there is that you can plug in any x value and you get a y value. Did this make sense for everybody? The linear equations, collinear points. Thumbs up if I should move on. Okay. So what I'm actually going to do now is that this guided practice and independent in practice will take a while to do. So I'm going to give you guys a break. We'll resume at around 1:10. I'm going to give you a break. Stretch, get water, use the restroom, whatever you need to do. And we'll meet back at 1:10. Is everybody back? Type here in the chat. Yeah. Okay, let's get started. Okay, we left off with this. We're talking about we left off with this plotting linear equation. We found out that you can plug in any x value and you still get a y value. It's always going to be in this line. It goes infinitely to the right and down and to the up and left. So we found out that these are 5 ordered pair solutions are collinear, and this is how you plot linear equations. Now we're going to go through a guided example of how you graph a linear equation. So first you find 5 ordered pair solutions, and you graph the 10x minus 5y equals 10. The first thing you do is solve for y. You convert it to slope-intercept form. Here we have it in standard form, 10x minus 5y equals 10. Now we use the subtraction property of inequality, subtract 10 on both sides. Then you're left with negative 5y equals negative 10x plus 10. Divide negative 5 on both sides. So negative 5's cancel out. You're left with y equals negative 10x divided by negative 5 plus 10 divided by negative 5. And y equals 2x minus 2. So it is standard form, slope-intercept form. We've done this before. Next, choose at least 2 x values and find the corresponding y values. Here is 5, so negative 2, negative 1, 0, 1, 2. After you do the math, you just plug in the x coordinate into the x value, and you solve it as you would any other with PEMDAS, any other order of operations used. So 2 times negative 2, then you subtract by 2. So negative 4 minus 2 is negative 6. Negative 4, negative 2 is 0, 2. So you, after you get the y values, you can make ordered pairs now. The x value goes in the first spot, y value goes in the second spot. So you're left with negative 2, negative 6, negative 1, negative 4, 0, negative 2, 1, 0, 2, 2. So these are your 5 ordered pair solutions. You're supposed to graph them. So how do we graph them? Okay. Sorry for starting early. So now that you graph them, you can see again, you see a line here, collinear. Connect the dots and you can make these arrows showing that they go infinitely in these directions. This is how you graph them. Make sure to use correct intervals or else it's going to be harder to graph them. And that's it. That is how you graph a linear equation using ordered pair solution that you found. Does this make sense how you graph linear equations? Thumbs up, thumbs down. Everybody else? Alrighty. Here's some independent practice. Find 5 ordered pair solutions and graph negative 5x plus 2y equals 10. Okay. Wait a little bit. We'll go over it at 120. Okay. 2 more minutes. Okay. I'm gonna go over it. If you haven't finished, just go along with what we're doing. Let me choose someone that's already done. Hey, would you mind unmuting your mic so that you can go through what you did?
Okay, so first I made an index.
Could you speak a little bit closer to your microphone?
Okay, can you hear me?
Okay. So what'd you do first?
So first I made the equation into slope intercept form, so it can be easier to like graph and like find points.
Okay.
Okay,
So
and then
what'd you do?
so you add 5x to both sides, and then
Okay.
and then after that you divide it by 2. So we can, and then it becomes
Okay. Now you have slope intercept form. What'd you do?
okay. Do you want me to do like the points first or the graph?
You could do the points first because you need to find the ordered pairs to graph it. What x values have you used?
X values I used 0, 2, 4, 6.
Okay.
Okay. Okay. And then I just plugged it in. And
Oh
then,
yeah. Okay. So I'll probably 2, 0, 4, 5. Okay. So the good thing that you did is you used intervals of 2 so that you can cancel out this fraction.
yeah.
So 5/2 times 0 is 0. 0 plus 5 is 5.
And then after
Okay. So what'd you do now?
okay, then after that I just like plotted the points.
These points, right? So 0,
Yeah.
5. This is 0, 5. 0. Okay.
It's two.
So yeah, what I'm gonna do here is gonna change these intervals. 5 and 15, 20, 25, 30. It's okay, you use different points. So 5, 0, plot that there. 0, 10. I mean, sorry, 2, 10. What am I doing? So I forgot to add the correct x values here. I added 0 instead of the correct ones.
Mhm.
So 0, 5, 2, 10. So 2, 10. 4, 15. 6, 20. Would be 8, 8, 25. So here, it's not the most straight line, but you should get a straight line. The arrows going infinitely in both directions. Thank you.
Okay.
For everybody else, did you get something like this? You don't have to use the same points, but you should still have a line that goes forever in the top right direction and the bottom left direction. Okay. Now let's say you have something like this. Let's say that you have a line like this. This is wrong. You have to have something that's similar to this going that way. Okay. Thumbs up or thumbs down if you want me to explain it again. If it's good, just thumbs up. Okay. So the next thing we're going to go over is horizontal lines. Some lines are not diagonal lines. Some lines are actually horizontal. Some are vertical. So let's look at an example of a horizontal line. Graph the following 5 points. Y is equal to -2. So there's no x. There's no x over here. There's no x. There's no variable x here. So what you can actually do is write 0x minus 2. When you have 0 in front of something, anything times 0 is 0, so it becomes obsolete. So you don't need it. But here we're gonna add a 0x so that we can see that it's actually a linear equation still. And by doing this, we can plug in x variables now. We can plug in random x values. For example, -2, 0 times -2 is 0, and 0 minus 2 is 2. So all the x values, no matter what you plug in, you can plug in 999 times 0 is still 0, times minus 2 is -2. So all the x values that you plug in is going to be equal to -2. So what you result in is this line right here, a horizontal line going from left to right with all the points, all the x values that you can go all the way here, all the way to the left to infinity, all the way to the right to infinity. It's always going to be a horizontal line, never going to become diagonal. So this is an example of a horizontal line. For a vertical line, x is equal to something. So here, we don't have a variable y. There's no variable y. So we can do the same thing we use for the horizontal line. We can add a 0 in front of y and say that this is still a linear equation. because x is equal to 3, we can plug in any numbers for y. -2, -1, 0, 1, 2, 999. 999 times 0 plus 3 is still 3. -2 times 0 plus 3 is 3. So you're still going to get 3 as x, no matter what you plug in, -2, -1, 0, 1, 2. So whatever you plug in for y, you're still going to get 3 for x. So because x is always 3 for no matter what y value you plug in, you're going to get a vertical line. One way you can sum up what equations that you can get vertical lines from and what equations you can get horizontal lines from is through this. If y is equal to some real number, then it's a horizontal line. If x is equal to some real number, it's a vertical line. So this is the general rule for finding out whether something is a horizontal line or a vertical line. Did this make sense for everybody?
Yes.
Thumbs up. Everybody else? Okay. Now without looking at the PowerPoint, what's the formula for a horizontal line? Anyone can type it in the chat. What is the formula for a horizontal line? Yeah. Okay, yeah. Okay. Now for a vertical line, can anyone write the formula? Make sure to use K. K is, yeah, good. No, it's not y equals K. Y equals K is for horizontal lines. Vertical lines, x equals to K. Just make sure to note that difference. Good job, everybody. We'll move on now. Make sure to remember that. It's going to be in the review questions. Okay, so here's an independent practice. Graph y equals 5 and x equals -2 on the same set of axes, so on the same graph, and determine where they intersect. So you're actually going to graph both of these equations and find out at what point do they intersect. I'll give you guys a few minutes to do this. Okay. I'm gonna wait for another minute or two. Good. You guys graphed it too, make sure. Okay, looks like everybody's done. Gonna pick someone who finished. Uh, Abel, do you want to unmute your mic and show me what you did?
Can you hear me?
Yeah, I can hear you.
Okay. First I graph y equals 5.
Y equals 5, okay. So what did you do at y equals 5? You
I
graphed it,
put I graphed it
right? Okay. So is it horizontal or vertical?
horizontal.
Horizontal, good. So every x value you plug in, no matter what, y is still going to be equal to 5. Okay, what about x equals -2?
And put a vertical line on the 2 on -2
Negative
on
2.
the x-axis.
So any value that you plug in for y, x is still going to be equal to -2. So what's the point where both of these intersect? This point right here, what is it?
-2 and 5.
-2, 5. Thank you. So we're given a vertical line, and a horizontal line, and we found where they intersected at -2, 5, x coordinate and y coordinate. Does this make sense for everybody? I know I already finished this really quickly. I want to make sure. Okay. Get back to the lesson. Here's some more independent practice. I'm going to give you guys a few more minutes to do this one. Note that the 12x here is supposed to be 1/2 x, and the the -34x here is supposed to be -3 or 4x. Find the ordered pair of solutions given the set of y values. There's no graphing involved, just find ordered pair solutions with these y values that they gave you. These are y values, not x values. You finished? Okay. Now we're gonna wait for another 2 minutes. $30. Okay. So I'm gonna ask someone on from random who hasn't gone yet. Efrat, do you mind unmuting yourself to show me how you solve this problem?
Okay, so for the one that the problem you just wrote down, I picked like the first coordinate is like -5. So I just found a number that will equal the number I got was -8 for the x value for -5.
-8. So what you so did you plug in -5 in the y for the y coordinate like this? Or did you try to plug in different numbers to try to find x?
Oh, I just did the second way you say that where I put different numbers to plug in where the half is.
Okay. So that's not always gonna work because sometimes you might have something like this, maybe something like this as your fraction. So it's not you can't always plug in different numbers. So the way that the easier way to do it is to plug in -5 because this is your y value. You just plug in -5 where you see y. Y is here, so -5. And we just solve this as we would any other linear equation. So we isolate the x term, add 1 on both sides. -5 plus 1 is -4 equals 1/2 x. To get rid of this fraction, we multiply by its reciprocal. Its reciprocal is 2. So that's what x equals, both sides. 2 times -4 is 8, -8. So x is equal to -8. So we get the same solution that you got to, but we solved it algebraically, and this is more reliable. Does this make sense?
Yeah.
Okay. So the ordered pair is -8, -5. X coordinate, Y coordinate. Okay, so since this made sense, let's do the second y value.
Okay.
So what do you do now?
So first you just put 0 for y.
Okay. Okay, what's your next step?
And then after that you add 1.
Yeah.
Then you times 2 for both sides.
Okay. Excellent. And your ordered pair is what?
2 and 0.
Okay. So that's how you do it. For the last one, I'm just gonna do it. Okay. No, sorry. 5. Add 1 on both sides. Get 6 equals 1/2 x. Multiply by reciprocal. X equals 12. 12. 12, 5. Ordered pair. So these are the ordered pairs for number 33. Number 34. Putting out of room here. Okay, let's do number 34 now, really quickly. So number 34, y equals negative 3 over 4 plus 2. The same steps that we used for number 33. So the y values we're given here, 0, 2, and 4. Let's just plug in 0 for y here. 0 equals negative 3 over 4 x plus 2. Subtract 2 from both sides. Negative 2 equals negative 3 over 4x. We multiply by the reciprocal. Reciprocal is negative 4 over 3. Negative 4 over 3. 2, negative 4 times negative 2 is 8. 8 divided by 3 is 8 over 3. So 8 over 3 equals x. Our ordered pair is 8 over 3, 0. Next one, we try it again. We plug in 2 for y. We plug in 2 for y. And we get negative 3 over 4x plus 2. Do the same steps. Subtraction property of equality. 2's cancel out. Left with 0 equals negative 3 over 4x. Multiply by the reciprocal. Anything times 0 is 0, so x is equal to 0. So we get 0, 2. Last one, y equals negative 3 over 4x plus 2. Okay. 4 is our y value. Subtract 2, subtract 2. 2 equals negative 3 over 4x. Multiply by the reciprocal. 4 times 2 is 8, so you get negative 8 over 3 is equal to x. So negative 8 over 3, 4. So these are ordered pairs for number 33. Does this make sense for everybody? Yes, no? Thumbs up, thumbs down. Okay. So now we have a PSAT application problem with what we're doing. This is not so much graphing, but actually interpreting what the graph means. So here the question is, a coffee shop is running a promotion where a number of free coffee samples are given away each day. The equation above, 110x plus y equals 1210, can be used to model the number of free coffee samples, y, free coffee samples, that remain to be given away x days, so this is the days, after the promotion began. After the promotion began, these are the days. What does it mean that 11, 0 is a solution to this equation? So being given what y means and what x means, what is the answer to this question? I give you guys 2 minutes to do this. Sure you got it right. Ten seconds. Okay, time's up. Type in the chat what answer you got for this question. Okay, everybody got C. C is the correct answer. Let's look at the other answer choices first. Good. So we said that X is the days after the promotion began. So right away, this X coordinate 11 is going to be corresponding to days. So here we have 11 samples that we can automatically eliminate A. And D also talks about 11 samples, so we can automatically eliminate D. Okay, so it's either B or C. Let's look at what we're talking about after 11 days. So it takes 11 days during the promotion to see 1,210 customers. Well, no, because it's talking about the number of free coffee samples that's left. This is what Y is talking about. They got X right, but they're not talking about what Y means. C says that it takes 11 days during the promotion until none of the samples are remaining. So a 0 is none, and this 0, Y, is talking about the number of free samples that's left or that remain to be given away. So if there's 0, that means that there's no free samples remaining to be given away. So the correct answer is C. Good job, everyone. Before we leave, we're going to do some lesson review questions just to make sure that everybody understands what's going on. The first question is, I'm going to ask people randomly, so make sure to be ready to unmute your mic. Aldo, what is the standard form of a linear equation expressed as? Aldo, would you mind unmuting your mic to tell us what the standard form of a linear equation is expressed as?
You call. Hello?
Yeah.
Can you hear me?
Yes, I can hear you. Okay. What is the standard form of a linear equation expressed as? You have standard form and slope-intercept form. standard form is this. Standard form is ax plus by equals c. This was in the beginning. Two variables are on the left side and a constant or a number is on the right side. So we have c, ax plus by. Just remember that. Thank you. I'm just going to go through the rest of these. Really quickly. What is the slope-intercept form of a linear equation expressed as? Well, that's whenever we have y isolated from the equation. This is slope-intercept form. Y equals ax plus b. B is some real number. A is non-zero. And y is the isolated variable. So whenever we're solving for y, that is slope-intercept form. Whenever it's ax plus b equals c, that's standard form. Two variables on the left side and a number on the right side. Slope-intercept form, variable on the left side, variable and number on the right side. What is the equation of a vertical line? And what is the equation of a horizontal line? We went through this already. Let's see if you still remember it. What's the equation of a vertical line? You can put it in the chat. Anyone? Correct. Equation of a vertical line is x equals k. So now knowing this, what is the equation of a horizontal line? Anyone?
Y equals k.
Okay, very good. Yes, y equals k. Okay, next question. What are points on the same line called? You can put this in the chat. I think we went through this on Tuesday as well. What are points on the same line called? No one? Okay. Points on the same line are collinear. Remember that word? Collinear. Just like co-workers work for the same company. The workers, they're similar, they work for the same company. These points work for the same line. They're collinear points. Okay. The solution to a linear equation is an n what pair? Blank pair. So what goes inside the blank? You can put it inside the chat. Solution to a linear equation is a blank pair. Anyone in the chat? Coordinate points. Yes, that's another name for it, but it has to have blank pair and it has to be corresponding with this word. You have an x coordinate, a y coordinate, and parentheses. That's called a what pair? Your solution to a linear equation. Three, two, one. Okay, it's close. It's an ordered pair. It's an ordered pair. Coordinate pair is close. Yes, their coordinate. Yeah, good. So their coordinate pair. They're called coordinates. You have x coordinate and y coordinate, but the parentheses, a more common form. The solution to the linear equation is an ordered pair. It's right here. Solutions to equations of this standard form are ordered pairs. So x, y is of ordered pair. Very good, guys. Thank you guys for joining me today. If you want to stay for the Amari class, I'm going to transfer the host to Brody. Make sure to tune in for the last summer class on the 30th, Thursday. I hope to see you there. Thank you.
Thank you.